Hi everyone, welcome back to our class. In this class, we will see previous questions which were asked in the public examinations from the chapter Differential Equation. Solve dy by dx is equals to e power x minus y plus x square into e power minus y. So that is dy by dx is equals to e power x minus y can be written as e power x into e power minus y. Since e power a into e power b can be written as e power a plus b, where e is the base which is common to both e power a and e power b, right? Plus x square into e power minus y. From this, e power minus y is common, that is e power minus y of e power x plus x square, right? That is dy by dx is equals to e power minus y can be written as 1 by e power y into e power x plus x square, right? Therefore, cross multiplying, that is e power y into dy is equals to dx into e power x plus x square. Now on integrating on both sides, that is integration of e power y into dy is equals to integration of e power x into dx plus integration of x square into dx. That is, we know that integration of e power y into dy is e power y, which is equals to integration of e power x into dx is e power x plus integration of x square dx is x cube by 3 plus c, where c is the constant. Since we know that integration of x power n into dx is equals to x power n plus 1 by n plus 1. Form the differential equation corresponding to function y equals to a into cos 3x plus b into sin 3x, where a and b are the parameters. So given function, that is y equals to a into cos 3x plus b into sin 3x. They have given a and b are two parameters. So we need to differentiate this function two times since they have given a and b are two parameters. So at first differentiating this y with respect to x, that is dy by dx is equals to a is constant, that is a into d by dx of cos 3x plus b is constant, that is b into d by dx of sin 3x. That is a into, here we know that d by dx of cos x is minus sin x, that is d by dx of cos 3x is minus sin 3x. And now suppose if we have here x, then the differentiation is minus sin x, but here we have 3x, so we need to differentiate this 3x again, that is d by dx of 3x plus b into d by dx of sin 3x is cos 3x, since d by dx of sin x is cos x. Again here we have 3x, so differentiating with respect to x, that is d by dx of 3x, that is a into minus sin 3x, d by dx of 3x is 3 plus b into cos 3x, d by dx of 3x is 3, that is equals to minus 3a sin 3x plus 3 into b, that is 3b cos 3x. So this is what we got when we differentiate this function with respect to x once, but we have a and b are two parameters. So again differentiating this one with respect to x, that is d square y by dx square, that is equals to, here minus 3a is constant, that is minus 3a into d by dx of sin 3x plus 3b is constant, that is 3b into d by dx of cos 3x, that is equals to minus 3a into d by dx of sin 3x is cos 3x. Again derivating this 3x with respect to x, that is d by dx of 3x plus 3b into d by dx of cos 3x is minus sin 3x, that and d by dx of 3x, that is equals to minus 3a into cos 3x, d by dx of 3x is 3 plus 3 into b, that is 3b minus sin 3x, d by dx of 3x is 3, that is equals to, here 3 3 is a 9, that is minus 9a cos 3x, here plus into minus, that is minus 3 3 is a 9, that is 9b sin 3x. Now taking minus 9 common, we get minus 9 of a cos 3x plus b sin 3x. And we have the function a into cos 3x plus b into sin 3x is equals to y. Therefore substituting this y here in place of a into cos 3x plus b into sin 3x, we get d square y by dx square is equals to minus 9 into y, that is d square y by dx square plus 9y equals to 0. This is the required differential equation for the given function. Give or find out the solution of x into sin square y by x into dx is equals to y dx minus x dy which passes through the point 1 comma pi by 4. So given the differential equation, that is x into sin square y by x into dx is equals to y dx minus x dy. Now taking y dx on RHS side, we get x into sin square y by x dx minus y dx equals to minus x into dy. Now taking dx common, we get x into sin square y by x minus y into dx is equals to minus x into dy. Now it can be written as dy by dx is equals to x into sin square y by x minus y by minus x. Now if we take minus common from the numerator, we get minus of y minus x into sin square y by x by minus x. Here minus minus get cancelled and dy by dx is equals to y minus x into sin square y by x. And here in this differential equation, we can see that in the numerator the power of y is 1 and power of x is 1. Therefore the highest power in the numerator is 1, and in the denominator the power of x is 1, so the highest power is 1. In the numerator and denominator the power is 1, that is common. Therefore we say that the differential equation is a homogeneous differential equation. So whenever we get an homogeneous differential equation, we need to substitute y equals to vx. Now differentiating y equals to vx with respect to x, we get dy by dx is equals to v plus x into dy by dx. Since we know that dy by dx of uv is equals to u into dy by dx of v plus v into dy by dx of u. Right, now we have dy by dx is equals to y minus x into sin square y by x by x. Now substituting this value here and substituting y equals to vx, we get vx minus x into sin square vx by x is equals to v plus x into dy by dx. Now here x get cancelled and remaining would be vx minus x into sin square v by x. Now taking x common, we get x of v minus sin square v by x, which is equals to v plus x into dy by dx. Here x get cancelled and remaining would be v minus sin square v. Here taking v on left side, we get minus v is equals to x into dy by dx. That is v get cancelled and remaining would be minus sin square v is equals to x into dy by dx. Now taking minus sin square v to the right side and x by dx to the left side, we get dx by x is equals to minus du by sin square v. That is dx by x is equals to minus cosec square v into dv, since 1 by sin theta is equals to cosec theta. Now integrating on both sides, we get integration of dx by x is equals to minus integration of cosec square v dv, and we know that integration of 1 by x dx is equals to log x, that is equals to here minus integration of cosec square v into dv is minus cot v plus c. Here minus into minus plus, that is log x is equals to cot v plus c, that is log x equals to cot into y by x plus c. Since we know that y equals to vx, from this v equals to y by x, right? And in the question given that the equation or the curve passes through the point 1 comma pi by 4. Now substituting x equals to 1 and y equals to pi by 4, in this we get log into 1 is equals to cot into pi by 4 by 1 plus c. Log 1 is 0 equals to cot pi by 4 is 1 plus c. From this c equals to minus 1. Now c equals to minus 1, substituting here, we get log x is equals to cot of y by x minus 1, which is the required solution for the given question. Find the order and degree of the differential equation d cube y by dx cube whole power 2 minus 3 into dy by dx whole power 2 minus e power x is equals to 4. Right, here you need to remember two things. Order is the higher derivative in differential equation and degree is the power of higher derivative in differential equation, which means degree is the power of order, right? And in the given differential equation, you can see that d cube y by dx cube means it is differentiated 3 times and dy by dx is differentiated once. So here in d cube y by dx cube and dy by dx, the higher derivative is d cube y by dx cube. So as I said, r is the higher derivative in differential equation. Here the order is 3, right? And degree is the power of higher derivative in differential equation, right? Here as d cube y by dx cube is the higher derivative, it has the power 2. So the degree is 2. Solve the differential equation dy by dx plus y into tan x is equals to cos cube x. So as you can see, it is in the form of linear differential equation, that is dy by dx plus p of x into y equals to q of x. So if we compare this differential equation with the given differential equation, then we can get p of x is equals to tan x and q of x is equals to cos cube x. Right? Whenever we get a linear differential equation, then to find the solution we have y into integrating factor is equals to integration of q of x into integrating factor into dx. So to find integrating factor we have a formula, that is e power integration of p of x into dx. Since from the given differential equation p of x is equals to tan x, therefore substituting in this formula we can get, that is e power integration of tan x into dx is equals to e power log sec x, since integration of tan x dx is equals to log sec x, and e power log sec x is equals to sec x. As we know that e power log x can be written as x. Right? Now substituting q of x, that is cos cube x, and integrating factor, that is sec x, here we can get y into integrating factor, that is sec x, is equals to integration of q of x, that is cos cube x, into integrating factor, that is sec x dx, that is y into sec x is equals to integration of cos cube x. Sec x can be written as 1 by cos x into dx. Here cos get cancelled, and that is y into sec x is equals to 1 by 2 integration of 1 plus cos 2x into dx. Since we got this, here whenever cos get cancelled, remaining would be cos square x, and cos square x can be written as 1 by 2 into 1 plus cos 2x into dx. From this, y into sec x is equals to 1 by 2 into integration of 1 dx plus 1 by 2 into integration of cos 2x into dx. That is, here if we take 1 by 2 on left side, it becomes 2 into y sec x is equals to integration of 1 dx is x, plus here integration of cos 2x dx is sin 2x by 2. Whenever we perform integration, then we add constant, that is plus c. Here 2y into sec x is equals to x plus sin 2x can be written as 2 sin x into cos x by 2 plus c. Here 2 get cancelled, that is 2 into y into sec x is equals to x plus sin x cos x plus c. So this is the solution for the given linear differential equation.